Hello and welcome. This is Robbie, W1RCP, and today I'm going to do a very basic introduction into what is an Arduino and how to use it for free at home before you get started. So this is the Arduino right here. And if you want to learn more about the Arduino, you can go to Arduino, Arduino.cc, and their website is put together very well so that you can go find out about hardware, software, their documentation. You can even check out the community and get help. They have a blog, and you can read all about how Arduino got started. So what's great about the Arduino is it is a microcontroller that you can use without a college degree. You don't have to know the inside workings of this thing. You'll learn it as you go, most likely. So what's great about it is that it has the in-circuit programmer, it has a power supply, it has a voltage regulator, and you can get started making electronics that are programmable really quickly. So we're going to go over one way today that you can start doing this for free and start messing around with it. And I'm a hobbyist. I like to tinker. Amateur radio also allows me another avenue that I can tinker. And I've made quite a few projects with the Arduino that are ham radio related. So if you want to get started, if you go to Tinkercad, tinkercad.com, you can go ahead and sign up for an account. I am going to log in, and I have a personal account, and I'm going to use my Google, and then I'm going to select an account. And now we're in Tinkercad itself. And you can do 3D designs in Tinkercad, you can do circuits, and you can do code blocks. So in circuits, what I'm going to do is click Create a new circuit. Now, what's great about Tinkercad is for the most part, you can experiment with basic electronics. It even has a simulator, which is a big deal because 10 or 15 years ago, having a spy simulator or something similar to that was hard to come by and not cheap. So, a few basic electronics principles will be in play, but what I'm going to do today is ignore the breadboard in case you've never used a solderless breadboard. And what I'm going to do is just build everything out in the open and just make point-to-point connections. So what's great is if you don't know how to do something with an Arduino, you can pick a sample circuit and then look at the code. So today we're just going to do a simple blink, and I'm going to show you a few more things after that on how to use some external switches of sorts, electronic switches, that you can interface the Arduino to other things. So the first thing I want to start off by talking about is that if you plug in with a USB, you get 5 volts of power and you get 500 milliamps of current that you can use to run anything on your Arduino as long as you don't exceed that power limit. These pins right here are the digital pins for the Arduino. And like I'd like to tell my students, these are not -3, -5, -6. These are your pin numbers. What this is a tilde, and it tells you that that is a pulse width modulation. And that is a little beyond what I want to talk about today. Pulse width modulation will take a little bit more explanation. Down here, you have analog pins, which can be used to read analog data, such as a temperature or something from another sensor. Temperature, humidity, there's a whole bunch of different things. The list goes on. And these can also be configured as digital pins as well. So you have 13 inputs and outputs over here, and an input is where you can read digital information, such as a high or a low. A high meaning 5 volts is coming in, and a low meaning that it's connected to ground. And then down here, you can do the same thing. These are inputs and outputs as well. And then you have this special header over here, and the most important ones are voltage in, which will give you the voltage through here. This input, you can go 9 to 12 volts. I wouldn't exceed 12 volts because the voltage converter right here will overheat. And so you would probably want a heat sink on that. So any voltage that you come in here, let's say you have 9 volts because you want to run a motor, you do not want to run a motor directly from these outputs. So these are like little digital switches themselves that you turn on and off using programming. And so if you need that voltage to go to a motor and then use a relay or a transistor to turn that circuit on, that's what you would use as voltage in. It'll come straight from here and bypass the voltage converter. So then you have 2 ground connections down here. You have 5 volts, which is coming from the voltage converter, and I'm sure I'm calling that the wrong name right off the top of my head. It's too early in the morning. And you have 3.3 volts, which comes off of another voltage converter that gives you 3.3 volts for those things that you can interface that might not want 5 volts. You can always check the data sheet for that information. Now, on the Arduino board, there is a reset button over here, but there is also access to that if you want to make an external reset. Let's say you mount this in a box somewhere, and you want to be able to reset the entire thing and start your program over. That is what this reset is for. Okay, the next thing, if you are new to programming, they have code blocks that you can use to make things happen. And like I tell my students, code blocks are great. It's a good way to get started, but these can get aggravating after a while if you have a very large program that you want to write or if it's complicated. So this is a good way to start, and I'll explain how this program works by hitting the start simulation up here. And so what is happening is pin 13 is configured as an output. It goes through a resistor to an LED and then goes back to ground to create a complete circuit. And over here, you have a comment, and comments don't mean anything to the program itself. That is for you, the programmer. And you drag over the blocks which says set built-in LED to high. Well, the Arduino does have a built-in LED, and that built-in LED is connected to pin 13. So another way that you could do is that you could set a pin to either high or low, and that would also, if you went down here and selected pin 13, that would also allow you to do the same thing as set built-in LED. So a dog just barked at us. Alrighty, so then await. These are delays in the actual Arduino C programming language. It waits 1 second. That allows you to see this LED has been turned on. Because if you didn't have delays in here, it probably wouldn't look like it did anything, because you have to give it some time for you and the program to be able to do it. So you to be able to see it actually happen, because this Arduino is quite fast, and we'll keep it as simple as that. And then you have a comment that says, hey, this is turning the LED off by making the voltage low. So you can see, even in block programming, when you start off with these basic programs, it is nice to be able to see what's going on in the automatic comments that they put in there. And that sets the built-in LED, which is pin 13, to low. And I must have stopped the simulation. So let's say that you're ready to copy and paste somebody else's code. Oh, well, we're not quite ready for that. If you want to go to the next level, now you can see when you drag and drop these blocks to text, or the blocks. Let's say we want to set pin, instead of setting pin 13 to high, let's say that we have something on pin 7. You can watch over here. This is the actual programming language that you would have for the Arduino. And when you make changes, these things can happen over here automatically as well. So let's set pin 7. Watch it happen on the right side of the screen in the code. Pin 7, and you can see it right here, and then make that low, and you can see that it changes to low. So these are your basic functions that you would need to know to get started with the Arduino. So the main 2 things, without any program at all, this is a basic program that does nothing, absolutely nothing. It is just void setup, void loop. You have to have those in there. This delay, you don't need that there. This is something that Tinkercad throws in there automatically so that it will improve the simulation. Otherwise, your time is going to be really slow. When you simulate up here, this time will slow down if there's something very complicated going on. So in void setup, you put things that only want to happen once upon power up or upon reset. And that void setup is where you would set something as a pin mode. And that is the name of the function, is pin mode. So if I were to, let's go back to control first, and let's go the forever loop. And that is what happens in void loop, is the forever loop. Now what's great about blocks is you don't have to worry about your void setup as much, because when you go to output and you set pin 13, let's go ahead and make this program really quick. Set pin 13 to high. Notice that it automatically sets pin mode. Pin 13 is an output. So knowing the parameters of this function pin mode is simply the pin number and then whether it's going to be an input or an output. Then to turn things on and off, digital write is what can turn a pin on or off. And pin 13, we are turning it on. We're giving it 5 volts. And notice that I still haven't used a delay down here. So let's just have a little bit of fun. And let's go set pin 13. See, it still keeps that delay in there, which is bad. But I just wanted to show you what would happen if you just do that right there. It does look like it's on just a little bit, but it's not quite happy enough because we don't have any delay to let us see that this is turning on and off. This is probably happening at pretty close to 1,000,000 times per second. So let's stop simulation. Let's go to control and let's put a wait for 1 second and another wait for, and if you don't put a wait right there, it's just going to be on. So don't believe me? Let's try it. It just looks like it's on because you're not giving it enough time to turn off. Again, it's probably going off for about 1,000,000th of a second. So when you put this next delay in there, and why am I calling it delay? Watch when I drop it. Boom. Delay for 1,000 milliseconds. That's 1 second. So that is how you can get something to turn on and off. Now, when you're ready to move on, I almost hinted to this earlier, but you can copy and paste someone else's code, and it gives you a warning because once you go away from blocks, you can't go back. It's not going to happen. Okay, so now you can do the same thing over here. You can write, let's say that I wanted to have another digital write. So I say digital write. See, at this point, I could have copied and pasted. But we're going to go digital write 13 high. You can notice that I cannot type very well. Let's say that we only want it on for 100 milliseconds. And then we go digital write. And you know what? You can copy and paste. So what if I wanted to copy and paste digital write low? I'm going to go Control C, Control V, digital write 13 low. And let's say that I wanted another 1,000 millisecond delay. I can copy and paste it. So now that I know what that does, and now you'll see it'll blink on for 1 second, off for a second, then it'll be a quick blip for a second, then it goes back. And void loop, unless you do something here at the end to stop it, it is going to continue in this loop as long as power is connected. So that is your basic introduction to the Arduino. I'm going to go into the next section and show you in documentation on the Arduino.cc website. If you go down to language reference, this will tell you everything you need to know about functions. You can learn about variables, and you can learn about the structure of an Arduino CC++ program. And they're also called sketches. So that's why this says sketch. and you have loop, and you have setup. So you can look at void setup right here is when the sketch starts, and you read all about how that works. And there you can even do a whole program up at void setup, although I strongly discourage that practice. And then once you have void setup, then you go into void loop, which is where your main program happens. And most programs, they're already going to be in a loop because you might be checking for inputs, you might be changing outputs. And now I'm going to show you two of my favorite circuits. And we are just going to stick with the basic on-off so I can demonstrate that. So the only difference, I'm going to change this. Instead of using pin 13, I'm going to use pin 5. And I'm going to use pin 5 and pin 5. In my next video, I'll show you where you can make one variable so you don't have to change all those pin numbers in your program. Okay, so I have switched to pin 5 to verify that this works. And we will double click on that and make it where it looks neater. Notice that it does exactly the same thing. It still blinks, I just changed the pin number. So we're going to get away from the Arduino, and we're going to go to all components for just a moment and show you all of the components. You can use switches, potentiometers, all kinds of things for inputs. But what I want to do is, let's say that I wanted to run a DC motor. Now, if you ran and connected in Arduino directly to the DC motor, you would probably be just fine. It would run as a DC motor. So we're going to connect this to the positive. Okay, maybe we're not. We've made a mess. So the way that you can do this is you can click on one of these terminals, make you a wire. I'm going to plug this into pin 5 right there. This you can connect direct to ground. That is a common point. I'm leaving this resistor here for just a minute, and I'm actually going to make it a 1K ohm resistor because I am going to use that in just a moment. So we'll go 1 kilo ohm. Okay, so if we did this, uh, it'll do it, and it won't give you a single warning about overheating or killing your Arduino. But you really want to limit the current going out of here. It can handle about 35 to 40 milliamps. By default, that is what it can handle. That's per the data sheet. I try not to exceed 20 milliamps out of any one digital pin. And this chip itself does have a maximum before it gets too hot. So you do want to stick with that. You could do this, but in real life, this is not quite legal. So there are two ways to do this. The first one, if we can find transistors, is to use an NPN transistor in it's in mode that it allows it to be a switch. So if you don't know how a transistor works, let's zoom in. A transistor, the base is your main connection. So we're going to connect the resistor directly to the base of the NPN transistor. And these would take a positive voltage to turn on. And that's obvious from my programming or electronics experience. NPN is my favorite. PNP I have not used as much. Now, for the collector, now I don't know what kind of voltage is coming off of VN. I don't even know if there is VN on this, so we're going to find out really quick. So hopefully there is some voltage coming from VN. We're going to find out. So the collector, you can think of it as collecting the voltage. And until this is turned on, it doesn't go any further. Then from the emitter, it's going to emit. And you can see I'm being real neat at this point with my connections. It should emit the voltage coming in from here. Now, transistors are a little more complicated than that, but we'll be all right. Let's see if there is a voltage coming in. Okay, there is, but it's not very much. Notice it's only 481 RPM. Let's see. VN may not have been the right choice on this one. Let's go to 5 volts and see what happens. Okay, so now you can see that you have it going in one direction. Now, there are other controls for motors. I just picked a motor because it was pretty easy to show that it's actually doing something. So if you wanted to switch the direction of the motor, then you would need 2 output pins, and you would use what's called an H bridge. That is beyond what we want to do today. Now, I should leave that transistor because transistors also have a power limit. You do not want to exceed the power limit of a transistor. A simple one like this, a 2N3904, 2N2222, those have a maximum dissipation of maybe uh, 1 watt, 2 watts. It's something very small. So they're going to get hot really quick. And if you overheat them, they'll go into thermal runaway and they will let the magic smoke out. Okay, so the last thing for this quick intro is using a single pole dual throw relay. Now, what's cool about a relay is you use a magnet on the inside to actuate the switch. So you have many connections on here. You have these 2 pins over here are going to be the what I would call the common connection for your circuit. And then you have normally closed, so this one's always on. And then you have normally open, which it's only closed when this magnet is engaged. Now, you don't want to run these magnets direct from the Arduino because most data sheets will show you that the amount of current that it takes to do this might exceed 20 milliamps. So always check your data sheet. Okay, let's make us some room. We're going to do the same thing. We're going to use the emitter. Now, I hope that I'm making these connections right. This should be, terminal 8 should be one side of this magnet right here. The other side, terminal 5, we're going to connect that back to ground. So I'm going to zoom out, and in real life, you wouldn't be able to shove 2 wires into this header, but in Tinkercad, for experimentation purposes only, you can. Now, you could make legit circuits on a breadboard and make them just as you would build them in real life. So, here we go. We have the common. We also need a connection from this section here. We know we could either connect at 5 volts or we can run a wire direct from here because that is the same potential. And we're going to run that to our input over here. That is our common connection. And then, if all is well, we will connect from terminal 2 of our motor, which was the positive, and sorry for all the scrolling in and out. And I'm going to make this red. Let's make it yellow just for fun so it really sticks out. Now, if I have done this correctly, because I did not practice beforehand, I figured I could just do this. Let's check our connections. We have our common. That is the voltage coming from the 5 volts. So that is good. We have these 2, which is our coil, is connected to ground and to our transistor. So what's going to happen is our transistor is going to be turned on. This is a lot lower power source. Not power source. This is a power drain here. So this load is going to be a lot less on our transistor, so it's not going to get as hot. And then we allow the relay to do all of the work through this connection. So let's see if it works. And it works just like it should. Yay! We have 10,000 RPM at 5 volts from our little 3-volt motor. Okay, so this has been an absolute crash course in how to use an Arduino. And then you can go up here and name your circuit. So this was called Basic Intro to Arduino. And that's what we're going to leave it as. So I hope that this has been fun and informative and that you have learned just the basics of how to use an Arduino, how to set your pin modes, void setup, and then in void loop, how to digitally write to some pin and turn it on, which is a high, and delay for just a little bit so you can see it happen, and then digital write to that same pin, turn it low, which means turn it off, and delay for another second. So I'm Robbie, W1RCP, and on my channel, W1RCP, which is ham radio, parks on the air, projects, and more, I am going to start a series on how to integrate Arduino into your ham radio projects. Thanks so much. Have a great day. 73 from W1RCP.